career spanning over half a century, it is my honor to introduce another man who is a legend in the steel industry. Donald Stuart Young was born and raised near Baltimore, Maryland. He served in the U.S. Naval Reserve and graduated from Drexel Institute of Technology with a degree in metallurgical engineering. And then in 1962, Don started in the Loop course, which was the Bessemer Steel Management Development Program. He was assigned to the electric furnace melting department of the alloy division inside the Bethlehem plant. Some of the older men that he worked with at the time still refer to that facility as the number one open hearth. And the number one open hearth was designed and built by John Fritz in the 1880s, 90s after he secured the government contract to rebuild that U.S. Navy fleet. The electric furnace melting department was then reorganized the building after World War II?
Yes.
Right.
About 1955, they called it.
Mm-hmm. And Don Young served there as a general foreman until the department closed in 1995. Then he was transferred to the EFM at the Bethlehem Steel Corporation Steelton plant, where he was employed as an ingot foreman. After Bethlehem Steel assets were sold, Don worked for successor companies as a contract worker, helping to make ingots for the forging industry until 2012. As a longtime volunteer with NMIH, as well as other industrial organizations, we are fortunate that Don so kindly and generously shares his knowledge of the iron and steel industry with us. He's witnessed great changes in the nature of steelwork during this latter half of the 20th century. We are fortunate to have him here with us today to talk about these experiences. Please join me in welcoming Don Young.
With that, I should retire because I can't beat that. My talk tonight is supposed to be on the changing working conditions that people experienced in the steel industry. So before that, we got to go back to what constitutes, quote, the steel industry. You might know that steel was made by our ancestors, the Etruscans, the Hittites, and other peoples well before the time of Christ. By the time of Christ, we have the Indians. Do I need the microphone? Hello? Is it hooked up?
Yes. Also take off the stand.
Okay, so we have an era of steel making that preceded the time when anybody wrote down how it was accomplished. But we do know it was extremely labor intensive because steel was more valuable literally than gold in those days. Then we enter the era when it's very first commercialized, say when Benjamin Huntsman invented the crucible process. He did not invent it, although texts say he invented it, but he lifted the technology from the Indians after the English subjugated the Indian subcontinent. So he took a process that the Hindus were used to making approximately a half a pound of steel at one time, and he expanded to make it in crucibles, which are refractory pots, anywhere from 40 to 100 pounds at one time. At the same time, we had entrepreneurs around the world taking wrought iron, packing it in retorts with graphite or carbon from either coal or charcoal, heating it for literally weeks at a time until the carbon migrated into the wrought iron and made a steel generally called blister steel, because when it came out of the retorts, the surface was blistered because if any gas that was in the wrought iron would make a blister. But you did get enough carbon dissolved to make steel on the surface. So these were the steels that were in common use before we come to the great era of what we call tonnage steel making, which started in this country in approximately 1870, after the Civil War. Up through the Civil War, the main construction material, iron construction material, was wrought iron. And the main way to produce that was in a puddling furnace, which was extremely labor intensive and took a very skilled person called a puddler whose process was melting pig iron in a puddling furnace. And a puddling furnace was a very small hearth furnace. It was sized for one man. He had a helper who tended a coal fire out of an ordinary bituminous coal. You could get a maximum flame temperature about 2,500 degrees Fahrenheit. And if you control this carefully, you could melt pig iron on a small hearth. The puddler then stirred this with a wrought iron rod, giving oxygen and flue gas contact with the liquid until he got carbon burned out. And he got a ball of wrought iron in this furnace. And when he had so-called brought the heat to maturity, he could take this ball out of the furnace with a pair of tongs. And if he was an average guy, maybe 40, 50 pounds, if he was a superior puddler, he may be able to make 100 pounds at one time. This then went to some means of squaring up the ball. A lot of times they did it on a cast iron floor plates, or they did it with hammers. Later on, they put it under steam hammers, and then it went into a rolling mill to make muck bar, which was the very first commercialized form of wrought iron. This was an extremely labor-intensive process, and the iron magnates of the time wanted to reduce the labor content and increase the output. In England, this led to contracting Bessemer, Sir Henry Bessemer, who was the Edison of his day back then. He was a professional inventor, a professional problem solver for industry. So he was contracted by the ironmasters of England to develop a process to get the labor content out of wrought iron and make the quantities bigger in production, because England was in the midst of its industrial revolution. It needed wrought iron like crazy. It could not make enough. So he invented a thing called the Bessemer Converter, and its intended purpose was to make bigger quantities of wrought iron faster. Guess what? It didn't work. Henry Bessemer still got his patent rights, still collected the royalties when it did work. A guy named Mushet, who was an English ironmaster, made it work. And the little thing he found out was he got a secret from the Germans. As he tapped the Bessemer converter, and he got basically liquid iron brimming with dissolved oxygen. He tapped that into a ladle, and into the ladle he put ferromanganese called Spiegel, or there was no word with Spiegel, but basically that means mirror iron in German. So you put that in the ladle with the tapped metal out of the Bessemer converter, and you got carbon steel, and the manganese was enough to kill it enough so you could make a rollable, saleable product. So when that process finally became commercialized in the United States, about 1870, all of a sudden we had the great era of tonnage steel making in the United States, in which you could make the stuff in as large quantities as the customer wanted. And the people who ran these organizations had already had experience with wrought iron, and they wanted to keep the problems they had with puddlers and their highly paid abilities out of steel making. So there was a double-edged sword here. So those are the three eras of steelwork. I'll concentrate on the last era, the tonnage steel making. I want to look in the tonnage steelworking era in Bethlehem plant here, which I'm most experienced, and in major steel mills in general. First of all, we'll say the people that looked at the unionized large steel mills and said, well, those guys in there, they sleep half the time, and the other time they're playing cards, and it's all mechanized, and they don't really work very much. Well, yes, we did that, but we did make a lot of steel. As far as the jokes are concerned, I'll tell you another little story. Remember, this was a dirty industry. Slag dirt was around, machinery dirt was around, dirt from rolling mills, dirt from dirty work clothes. So therefore, the jokes came in clean. Somehow they went out dirty. When you look at the manual work that was in the steel mill, remember when the Bessemer process came, that was the brand new development, which changed an ironworks making wrought iron to a steelworks making steel. Everything else stayed pretty much the same until they developed stronger rolling mills, stronger machinery to handle the tougher steel. So the jobs that went along with these stayed, and they were very labor intensive and hard jobs. I'll give you a little example here. Now, this is open hearth plant. I hope you can see this. This is the #1 open hearth in the Bessemer, in the Bethlehem plant. This was opened in 1887. You see 2 ladles were tapped from open hearths. And my research on this plant was when the place was built and put in service in 1887, it had an overhead crane, but that was not strong enough to lift a ladle full of steel. It was only good for taking the empty ladle away and dumping it, and bringing the empty ladle back and setting it up against the furnace ready to tap. So this ladle was rolled on a carriage along rails from the furnace to the casting pits. And if you look carefully, you can see there's guys with bars. They're jacking this carriage along with bars between the wheels and the rails. So this is the level of, if we did mechanize, we did enough to mechanize the melting unit and the steel making unit, but we're still back to the same kind of use of labor as was in the iron mills of the previous era. You can see this translates to, we'll come one step technologically further when the open hearth is supplanted by the basic oxygen furnace. And here's a guy in full protective clothing. This is a ladle of iron from the blast furnace being dumped into the basic oxygen furnace. And he does nothing more than signal the crane. There's nothing on here that he can do by hand. Go back to some of the other labor issues in the plant. When the steel mills were formed, both here and in Pittsburgh and other places, there were unions in existence, and mostly they were unions of skilled people and predominantly puddlers, because that was so difficult. Only certain people could handle the physical strength required, the physical endurance required, and the skill required to puddle. So the attempts to unionize the steel mills were generally rebuffed by management. And you got to remember that they were successful literally in all attempts up until 1937, when the United States Steel was finally unionized, in 1941 before Bethlehem Steel was organized. So you go from basically 1870 to 1940, or 70 years of working in steel mills before you had union protection. I came into this plant in 1962, went right to the electric furnace melting department. I had the honor, I would say, to talk to people who had started in the 1920s. They were 40-plus year guys. And they told me the stories of how things were in the 20s and the 30s. In this plant here, there were 2 shifts. There was a day shift of 11 hours, a night shift of 13 hours. And the general opinion was management figured you were going to get at least 2 hours sleep on night shift. That was the thought behind this, as given to me by these people. The other reason they stuck with 12-hour shifts was the open hearth in those days in my shop tapped about once every 12 hours. So with 9 open hearths in that shop, and maybe 7 of them running on any given day, you'd have 14 heats tapped in a 24-hour day. So the activity was not just jammed up. You would get a break between the times you had to work and the times you could sit and rest. In time, open hearths got to where they would tap every 8 hours with normal aspiration. And right before the era of basic oxygen furnaces, we learned to put oxygen into open hearths, and we get open hearth tapping down to 4 to 6 hours. So one of the things that I've got to point out here is that jobs that came into the steel industry from the wrought iron era and were hand things like just shoveling up spilled material stayed that way for literally a century. Because unless somebody decided they wanted to mechanize this, it didn't get mechanized. So we had lots of things that you would think and look at today would certainly be mechanized. But in a day of cheap labor, up until the time of unionization, there was no need to, so they didn't do it. They just had scores of laborers in any department that cleaned up messes, cleaned up spilled slag, transported material by hand, used hand tools for any kind of a job that was small enough to do by hand, and only the great big steel-making machinery was the modern stuff. I'll give you some personal experiences from the electric furnace melting department that I went into. In 1962, I remember refractory brick was delivered in boxcars. Every brick was hand-loaded in that boxcar by hand. In between courses was spread straw so the brick wouldn't scrape or break themselves up in transit. When they got to my unloading track, we had a bunch of CSL laborers. CSL stood for Central Something Labor. These guys would unload the bricks one by one, load them on wheelbarrows, take them onto the furnace floor, stack them up as near they could the furnaces or the ladles where they'd be used. And then they'd be available for the bricklayers when the bricklayer gang came. This was done one brick at a time by hand in 1962. You know, fork trucks were available in the Second World War. When did they get fork trucks? When the brick suppliers started palletizing the brick to come to the plant. And why didn't Bethlehem Steel change this practice beforehand? It was one of the things that was stuck in the section called Article 2B in the labor agreement. You can say what you want about union management back and forth in the labor agreement, who was at fault with what went bad. But Section 2B basically was a section which said, once you establish a process and a crew size to do that process, that's agreed to by union and management. So you have a crew size established or an established process, and it stays the same. So if the crew is established and they're getting the work done, why buy them a fork truck if you don't have to? Eventually they had to because the material started coming in pallets. One of the other things at EFM, when anybody started there, they were issued their safety equipment, which in the beginning was not very much. It was a hard hat, shoes you had to buy yourself, gloves which were issued by the department. Anything after that you bought yourself, but you were also issued your own personal shovel. Because no matter what your job was, you had to clean someplace up, or you had to use that shovel for the furnace or the pits or refuse or slag or something. So everybody had their own personal shovel, and they were expected to have it. And I wasn't supposed to give you a replacement until you turned in a worn out or broken one. And some guys did break the shovels, and I think they broke it out of frustration to show what they could get away with. But certainly I gave them a new shovel because I wanted the work to get done. Some of these games were, we didn't work all the time. We did have time for fun and games, despite the rigors of the steel mill. I'll just give you an instance. We had one of the he-men, and believe me, we had he-men, and they called themselves Iron Men in the department. The guys that navigated, or I should say navigated, but drifted towards the hard, hot jobs. These were the Iron Men. And one of these guys was Angelo Guido, and he was short and stocky, built like a tank, and nobody would want to tangle with him. But guys would get behind him and tell Italian jokes and then run like hell, and they knew he couldn't catch him because he was too short and stocky. Well, I can remember one instance when this happened, and these two guys run away, and all of a sudden Angelo Guido's shovel goes like this. It goes right between their heads. And if it hit a head, I don't know what I would have done, because I will admit at this late stage that there were accidents that happened because of horseplay. But when I wrote the suspensory slip, the word horseplay wasn't in there. They were always doing something the company needed, and they were always wearing their full protective equipment when the accident happened. And I learned that the hard way. Because if you're out in the shop and you expect the gang to do the work that you need to get it done, you don't want any hard feelings from the guys working for you. I learned that lesson. I wasn't on the job very long when I had a guy that got burned on the pouring platform on a very hot day. And so we went to the dispensary, and I hadn't even learned how to write a dispensary slip at that time. And the boss is after me, and he just says to me, well, how did he get burned? I said, well, it was a hot day. His coat was open. He got, well, you have to write that guy up for a discipline. That's against the company rules. He's supposed to have his protective coat buttoned up in front just in case he gets the steel splash. So I'm thinking about this, and I don't know how many days went by, and the guy would keep asking me, well, did you write that discipline yet? Did you write that discipline yet? And finally, I hadn't written it until he forgot to say that anymore. Because I figured if I wrote a discipline for some guy doing his job, staying on the job till it's done, and then he goes to the dispensary, well, if I write a discipline for that guy, I'm not going to get work out of any of these guys on this gang, right? So you learned as a foreman that what you wrote was not always the truth, but you did write what it took to get the job done. And that phrase, get the job done, is something I learned in other labor issues because it was against the rules for foremen to work. I was a foreman. In fact, the National Task Partly Law specifically said that if I was a foreman, I was a member of management, and the contract there said I couldn't work. Well, in electric furnace melting, everybody worked together, I thought. I shouldn't say everybody, 98% of them. And one of my jobs to make the department run smoothly was to see that everything ran well and everything was in line. And so if I saw somebody falling behind or some operation was falling behind, I would chip in and help the guys. Of course, that was foreman working. And very seldom did anybody ever complain about getting help. But every once in a while, somebody had some way they wanted to get back at me for something else. And so they would turn me in for foreman working. It was called instant lottery. And it would go before the superintendent. I couldn't settle that on a foreman to worker basis because it involved me. It went right to the superintendent. And it took me a couple of these before I hit the magic phrase. But sir, you wanted the job to get done, didn't you? And then I get blankety, blankety, blank, get the hell out of here and get back to work. And they paid the guy. But we had very few disciplines, very few write-ups of people in the electric furnace melting because everybody really worked together. I give the guys I work for lots of credit. I did have a few guys that didn't work, and guess what? The union carried them. And I had guys that wanted to turn me in for something, and they went to the washroom, and somebody else in the gang convinced them that they shouldn't harass me.
Yeah.
I'll talk about the management philosophy, too, that changed in my era here. I came in an era when we still had the old-style superintendent, the guy who reigned like God Almighty on his department, thought he could get away with murder, thought nothing about cussing anybody out, and acted just like the days when there wasn't no union and he could do whatever he wanted to. And over the years, that changed to become more amenable superintendents and upper management, but it didn't disappear completely. So some of these changes were brought by the union, some were brought by management, but labor-management relations did progress from hard-working guys and hard-driving superintendents to, I think, better working together in the latter years, because in the latter years, you also got a better educated workforce and you had a better educated management force at the same time. Also in the same period, look at the evolution of personal protective equipment. When I went in there, I started the Sparrows Point plant in 1956 as a laborer. When I went in, I was told to buy my own pair of safety shoes. If I wanted anything else, I had to buy it. I wasn't given gloves, I was given hand protectors. They were leather pads shaped like your palm with a slot in the end so you could stick your wrist through. and they protected your palms. I worked in the 56S hot strip mill, stacking sheets, sheared sheets. And you caught them coming off the shears. If you didn't have hand protection, they'd cut your hands up. I went through a pair of those every shift, sometimes more than a pair. But the company didn't have to buy me gloves, so they didn't. If I wanted gloves, I had to buy them. And now in the very ending days here, if you saw the spacesuit back here in the museum, that's basically the kind of protection you had to wear to be around molten metal. When I went in the electric furnace melting here in 62, when you worked on the furnace side, up on the floor, you didn't have to wear any protective equipment other in 62, except the hard hat. They gave you glasses, furnace glasses, and safety glasses. But gloves, we gave out to the department, but clothing, yes, you had to wear safety shoes also, but any clothing was whatever you wanted to wear. When you got down on the pit side and you're actually tapping and handling the molten steel, you had to bundle up in a protective wool coat. And we had two types, wool and asbestos. And you know what the asbestos industry disappeared basically because once the lawyers found out you could get sick from asbestos, they glommed on and sued them for all they're worth and put the asbestos industry out of business. And I always say that was bad because the asbestos industry over the years, from when the steel industry started until they disappeared, saved a lot of lives. Far more people probably than ever died from asbestosis. I still have some asbestos home just in my collection of things from the steel mill. One day, the guys in the spacesuits came to the department and said, any asbestos, give it to me. They got to wrap it up in plastic sheets and dispose of it. I saved some just for old time's sake. I'll talk another, let me go through the pictures here too. We've had three eras when we've had women in this mill. World War I, we had a lot in the shell shops. Here's a picture from the World War I era. Take a notice for the safety equipment that these young ladies had. You see they have eye protection. I'm sure these are wool smocks because wool protects you from the heat and does not catch on fire very well. But look, bare hands holding the torch, bare hands holding the brazing rod. I'm told by the caption of this, that came to this picture, they are raising fins on projectiles, either bombs or shells, I'm not sure. But in the shell shops, they wanted to employ women because the women were much more careful handling explosives than the men were. Here's another picture of women. This is also World War I era. You can see the clothing is probably dictated, but that's certainly not safety in front of machine tools. They have goggles for chips, no gloves. They're expendable, unfortunately. This guy's working outside, no safety equipment at all, probably none required. And even though this says Bethlehem Iron Company, does not mean it was taken in the era of Bethlehem Iron Company because these cars ran around the plant. Even in my era, starting in 1962, there were some railroad cars running around this plant still lettered Bethlehem Iron Company. Doesn't mean they actually came from the Bethlehem Iron Company. It means somebody painted in that whenever they were put out in the plant. Okay, I just want to talk about some other skills that were predominant in the plant in my era here. In my shop, the skill jobs were crane operator because everything had to move by crane. You had the highest paying job was the first helper, the guy who managed the furnace. The mold leader, who took care of the mold gang, was high paid, and the steel pourer were high paid. Those were the four high paid jobs in the department because they basically controlled the product flow in the department. And you had a secondary row of jobs of skilled people that supported them. And you had a third level of jobs That was from labor up to the helper position that supported them. One thing that kept my shop running smoothly was we had an incentive program which was based on tons of ingots out the door. So everybody got paid on one incentive. It made everybody work together. It was so nice. Nobody argued about it. I was a temporary foreman in many other shops. I should point out that I was a college-educated foreman in EFM. Quite a few times I got picked out to go to where they needed a temporary foreman, someplace else in the alloy division. I guess they figured I could learn on my feet in a couple of days or a day or maybe just the first 10 minutes of a shift. But anyway, I was in shifts, in shops where discipline was crazy. The outlook of the people in management was not very good. And a lot of times people had individual industrial engineering contracts on the job they did. So they were interested only in their little workspace in front of them, and they couldn't care what their buddy next door was doing. It was a big help to my department to have it all under one contract in the electric furnace melting shop. What was one of the big things to reduce people? Computers. Guess what? It didn't really happen because the union fought it tooth and nail, right? But we had computers. Now, I can remember when Bethlehem Steel made a great big deal of getting the IBM 360 computer system here in the office. I didn't see anything that did out in the plant. On a foreman level or working level, you didn't see that. All you did was read about it in the Bethlehem Review and maybe the local papers. The first time the computers came in the mill that did anything were in 1969 when the combination mill went online with computer control and the basic oxygen furnace went online with computer control. And these things did things which because it was a new installation, there was no crew size. So right away, they could assign any work they wanted to the computer and any work they wanted to the workforce. And this was the only way you could break this crew size thing was to build a new facility and get new staffing levels. Now, this worked fine. I think the combination mill and the BOF worked fine. They started up and they did their job. When the computer controls or consoles, I shouldn't say controls, the consoles first came out into the shop level, EFM, they were for entry of reports. And I and the other foremen were going to really, really, really hit these things with sledgehammers because you'd start this thing up and on the screen would come a picture of the very same report that you used to fill out with a pencil at your desk. So it took you maybe a couple of minutes to fill this out with a pencil at your desk. For people like me that couldn't type, it took us a half an hour like that to fill the same format. So we, foremen, hated the computers. And what was worse than that is if something happened and you didn't get the intended result, you had a helpline to call. And you called the helpline, and the person on the other end very graciously blanked the screen and put the form up again so you could start all over again. So we hated the helpline people as well as the computers. And this system went through, I kid you not, even to when I went to Steelton after 1995. You key in the company computer, and the form you needed to fill out was the very same as the old paper form. So this did not help production at all. I'm sure in other facets of the mill management, it helped immensely. In Steelton particularly, because the computer ran the furnace, the computer ran the castings, and probably a lot of other things in the mill, but not for the foreman. So this takes me to Steelton. When this place shut down, I always said that I was put on a truck along with other well-worn out equipment from the electric furnace melting and taken to Steelton like a serf and told to set it up out there and make big ingots and ship them back here to Bethlehem. And that's basically what happened. I was amazed at the difference in management philosophy at Steelton as opposed to the Bethlehem plant. The Bethlehem plant, what impressed me in many cases was that there was always somebody around and always a part it seemed to fix literally anything. When you went to Steelton, that concept was gone. They believed it. When it breaks, that's when you decide you're going to fix it. That's when you go for the part you need. And one of the reasons I believe that Bethlehem shut the Bethlehem plant down and kept the Steelton plant was the maintenance cost per ton was probably 1/3 at Steelton what it was at Bethlehem. Easily. Because this was a much more complex plant. Now that all takes us to besides the management philosophy change and the work change, we've gone from an era of hand tools to mechanization, and then we finally got to Steelton automation, because at Steelton, the furnace didn't run without the computer running, the caster didn't run without the computer running, order entry, so you knew what you were supposed to do, didn't run without the computer running. So when I got out to Steelton, I had a system where nothing ran unless I got it from the computer or the computer told something what to do. It was an entirely different setup from here. And maybe if we had had that in Bethlehem a decade earlier, this plant would have stayed open. I doubt it, but maybe. One other item on personnel. You talk about individual people working and the tools they used. I talked about, we gave shovels, we gave personal safety equipment to people. If you were a craftsperson, there was a dividing line agreed to between the union and the company on what hand tools you got. If you were an electrician, your small common hand tools you bought yourself. Pliers, hammer, screwdrivers, anything which was specific to the job, a larger, more expensive tool, the company provided. And that was a big reason to actually prevent employee theft. We don't want to use that word, but that's what it was there for. I remember an instance when Bethlehem Steel came out with bright yellow plastic flashlights with Bethlehem Steel on one side and Safety First on the other side. And the maintenance foreman came in my superintendent's office when I happened to be there with this flyer that said these things were available. Says, well, I want to get these for my men. Can I order them? He certainly. He says, okay, I'm going to order 30 of them. Wait a minute, you have 15 guys on your gang. And the maintenance foreman says, one for each toolbox and one for each club compartment. And that was exactly the way it worked. So, do we have any questions? Well, we can show some pictures here because, can I show all these pictures? I don't think so.
When did EFM close?
EFM closed 1 week after the official closing of November 18th. It closed on November 25th. So we made steel for 1 week after the official closing of the plant. And then they just shipped us, me and a couple other guys and the equipment to the Steelton melt shop to make big ingots there. Here's another picture taken from EFM. This is pouring steel out of a ladle into mill molds that would go to the rolling mill. This is the mold here. This is called the hot top. That holds the reservoir of molten metal over the ingot. So as the ingot cools and contracts and shrinks internally, this reservoir of molten metal up here fills that void. So when you get to the mill, it's rolled. This part is cropped off and thrown away. And the bar that you make from rolling that ingot is solid. If you don't have this, to be killed steel, your bar will have what they call pipe in the center, or a central failure. This fellow up here is in his safety gear. That's Bill Mahala. Was a steel pourer many years, finally became a foreman. And this I always say was the toughest job in my department, because the steel pourer was responsible for making up the ladles, which mean that he got a ladle which had been cleaned, had the nozzle set in the bottom by a nozzle setter. He then got rods, which were made up by a guy whose job was to make rods, which had the stopper on the end. He set that in the ladle, adjusted it with the opening mechanism so the stopper went up and down and always made it with the nozzle on the bottom of the ladle. He was responsible for that. So he made up all the ladles for the next shift. And then he poured all the ladles that the furnace tapped into on his shift. So he was a busy, busy bee. Now I'll tell you another story how I almost got in trouble. I had a Jake Beblavi was my steel pourer, tough as nails guy. So I come into work and, oh man, the place is running like just, it's just active. So one furnace taps, I tell Jake, this is tap. Next thing is this furnace tap. Next thing, this one. Finally, I go to Jake and next furnace is tapping. And he blows up and screams at me and says, I just put my lunch in the oven. I don't get a chance to eat blankety blank Beth Steel and you too. And you know, all the words. So I realize he's right. I've already given the furnace permission to tap, because if I don't give the furnace permission to tap when they call up, I'm going to be in front of the superintendent's office, because my whole job is to have everything ready for when that furnace is ready to tap. So at that time, the nozzle setter was the assistant to the steel pourer, and he went with the steel pourer when the furnace tapped. He went with the ladle, and he helped open the ladle, and he took the tests from the ladle, ran the tests up, and sent them to the metallurgical department. So I said to the nozzle setter, a guy named Nouse, didn't get along with very well. He said, you come with me, I'm going to take this heat for Jake. So first thing Nouse says, I don't think that's a very good idea, Mr. Young. I said, uh-oh, I'm going in front of the boss tomorrow, right? So I go, we get the ladle, take it out. He helps me unlock the ladle. I start pouring. He takes the test and he disappears. I finish pouring the heat. I dump the slag out. I send the ladle back. Then I go see Jake. He's finishing his lunch. Thank you. But the next day I expect, oh boy, am I going to get it? Well, I was told that certain people talked to Mr. Nouse in the washroom that day and nothing happened the next day. Okay, how do we go through some of these pictures? This is a cover of the book I wrote with Ann Bartholomew. Ann Bartholomew was the editor of all the Canal Museum books, so she took care of my spelling and my grammar and my syntax, whatever that is. Find some pictures with people in it. Child labor, which didn't occur too much in the steel mills, although guys that worked in the 20s told me that it was not uncommon when they worked an 11 or a 13-hour shift for one of their family members to come in at half shift time with a hot meal from home. And evidently the guards and the people knew them, and they could come in. A kid, a wife, daughter, girlfriend could come in and bring you a hot meal. You couldn't do that today. I can talk about all these. Here's the cast floor of a blast furnace where they're actually making pig iron. You can see the central runner comes out. The metal runs over to that side where all those individual molds are in the sand. So each one is fed by a salvar, and the individual pockets are called pigs. And that's where the term pig iron comes from. And you can see these he-men here working bare to the waist. They aren't afraid of sparks, because not only do they put up with the heat from the furnace tapping, as soon as that pig solidifies, they're in there breaking up with hammer and tongs and taking it out and stacking it, and then getting the sand bed ready for the next cast. And they're probably working 12-hour shifts. Go ahead. Fritz, this is the man who's documented across the room here. Very good exhibition put up by this museum. How are we doing for time? Bessemer furnace blowing. We started Bessemer Steel. Okay, here's company engine. The company, of course, had its own railroad, although it was founded by the Lehigh Valley Railroad. And you can see 5 men there. Remember, in this era, 5 men was the standard crew for a train. Engineer, fireman, conductor, and a head end and a rear end brakeman. And the rear end brakeman was also flying. Here's a picture I showed you from electric furnace melting when it was open hearth number 1. You can see the open hearth tapped into ladles. The ladles are shoved along the track by guys with bars. And the ingots poured in the pit. And the crane can take the empty ladles away and take the ingots out, but not lift the full ladle of steel. Go ahead. Erecting the Ferris wheel at the 1893 Chicago World Fair, which at the time was the largest steel forging we had made. And if you want to see this in action, you can go to Prater Park in Vienna, where they took the same plans that we used and built the same Ferris wheel. It still exists today. And to make it safe for today's operation, they took off every other people holding basket. It's still okay for today's safety factors to take people on a Ferris wheel line. You can see the number of people around. The press and the material handling is mechanized. Everything else is still done by people. The guy with calipers there to measure the thickness. And if they see a defect, somebody goes up there and tries to scarf it out or chip it out. Go ahead. Go ahead. What you don't see in this picture are stands for that mandible that's being supported by the frames in order to hold that in position for the press to form that ring. Otherwise, it's a very good shape, very good shot. Once again, lots of people around. I'm sure that somebody in the era could look at that group and tell you what their ethnicity was by the way they dressed. We had, in the good old days, we have examples here, there were signs in 6 languages around the plant, mostly Eastern European languages. And one of the company's customs in the Bethlehem Iron era was they have a bilingual foreman who spoke English and spoke some Slavic language, and his whole gang was the old country Slavs, and he could communicate with them. So you didn't have to have English-speaking people to do the jobs. Charles M. Schwab, who we could have a whole talk on him, his house. So we talk about people, look at the people. And I'm sure this is a staged photograph because Schwab initiated the bonus system, which evolved into our industrial engineering department to pay a product bonus for people working, so they'd have an incentive to work beyond what they might normally work. It also pertained to the foreman. And interesting, for my bonus in the electric furnace melting shop, I told you the bonus was based on ingot ton weight out the door. The unionized guys in the shop got that very simple calculation. The foreman, superintendent on down, got ingot tons out the door minus any rejected ingot tons from anything that happened later on that was blamed on the shop. And of course, you can imagine that if anything happened in the further processing of the ingot, the onus was on those. Blame the melt shop. Don't blame ourselves. So I think we took it pretty hard sometimes. We took a hit that we didn't deserve. But that's not for me to solve. That was for the metallurgical engineers to decide. One of the great strike-breaking episodes when we had to call the state police. And this is open hearth furnaces, charging machine up there, which replaced hand charging for old furnaces. Here's the tapping side up here. The furnace tapped into a ladle. The ladle was sized the same as the capacity of the furnace, so when the ladle filled, the slag ran onto the ladle and off the top of the ladle over to the slag symbol on the left. This picture of a guy is running a bar through what they call the wicket hole in the front of the open hearth on the charging floor. Appears many places, and it's been titled Men Tapping in Open Hearth, which is absolutely untrue. You tap the furnace from the other side of the open hearth, and the only reason guys would run a long bar in there is they've got a puddle or a bridge in the already tapped furnace where their hearth is showing, and they're trying to knock that down. So the next heat they make, they're going to drain properly. This is something you wouldn't want to have to do on a regular basis. The top picture is a posed picture of a man removing a crucible from a crucible furnace for crucible steel making. Crucibles are piled up in the back. The picture is staged because there's no fire in the pit. If that was actually operating, he'd take that cover off and he'd need all that protective equipment on him, which the old timers tell me they wrapped themselves up with burlap and doused it all with water in order to work in a condition like that. Because the temperature in that pit, which he's straddling, would be on the order of about 2,700 degrees. This is a rolling mill, where the only part is mechanized. The workers are handling the bar, which may weigh maybe 300 pounds for a whole bar, but they can lift it, multiple workers, and you only have to lift one end to get it into the mill. And so it goes through mill stands from one side to the other. And the guys are putting it into the mill with tongs, catching it on the other side with tongs, transferring it to the next mill stand with tongs. That was a very dangerous job because sometimes rolling mills had cobbles, which meant the bar didn't go through the mill the way it was supposed to. It jammed on something, it maybe whipped around. Very dangerous mill. Go ahead. This is the Great Gray Mill, invented by Henry Gray. The licensing was bought by Charles Schwab in order to put Bethlehem on the map as a structural steel maker. What you see in the center of the portion is the universal stand, which contains both horizontal and vertical work rolls. To the right is the supplementary mill, which just rolls the toes on the flanges. Up until this time, Bethlehem and other mills rolled I-beams. I-beams went out of vogue when this mill came into usage, because this rolled Bethlehem wide flange beams. What name stuck in the vernacular to this day? I-beams, right? But anytime you see structural with flanges on it, it's wide flange structural made on a mill like this. Go ahead. This is, I'm pretty sure, the 22-inch mill, free high 22-inch mill. You can see guys with tongs, that's a red hot billet going through the mill. And these guys' job was to turn that billet 90 degrees, but it needed to be turned 90 degrees to go through a different pass. So this was a job ultimately mechanized, but in this era, labor was cheaper. You just put guys out there with tongs, and you can look at that loom, and if that's 10 by 10 and 15 feet long, that's 3 tons of steel right there. And you got to flip it on its side with tongs. And 2 guys. And of course, one guy is jumping over it to help the other guy to do that. Go ahead. We did have safety equipment in the early 20th century, but not much. Once again, I think this is a posed picture. I don't think you'd have that many guys out there. All those guys would be all over the yard. They wouldn't be all just standing around for the photographer. Working conditions for building the place and working conditions for the board once it's done. And this is the era of women in World War I. Mr. Grace? This press here, this is the one that's outside in our yard. So that's in weldment. It ended up in the weldment shop, but right now it's in the armor plate fabricating shop. And with those guys I close, you can tell that plate is cold. It's also had some machine work done on it. So it's being bent to shape cold. Steel products. The blast furnace casting floor, but this time the pig beds are gone and it's casting into ladles. Inside a furnace. So these are craftsmen. These are probably, when the blast furnace went down and went for a rebuild, you had all the crafts literally in one place trying to do this job. riggers, pipe fitters, carpenters, bricklayers, and central labor, all cooperating to get the job done, because once the furnace went down, the whole idea is clean the thing out and then rebuild it again. So you had two classes of rebuilding blast furnaces. One, you literally took the whole furnace down to the bed and you built a whole new furnace back up. And the other more common was a reline. You took all the refractory material out of the stack, you straightened up the stack plates as best as possible, and then you put new refractory back in. And in colonial eras, furnaces generally ran seasonally. You'd fire it up in the fall and it'd go out of service in the spring because it was just too hot in the summertime. And finally, we got to where we could run a furnace around the year, and then a year was a campaign. And when we finally got to the 1860s, when this place opened up, we still had a year or maybe a year. And by the time this place shut down, a campaign on the blast furnace might be 12 or 13 years. So it just shows how we improved things as we went forward. Go ahead. I'll go back to this shot. This is the blast furnace gas internal combustion engines driving air compressors to power the blast furnaces. This place had an assigned crew. They kept that shop when it was running spotless. Every place in the steel mill literally was dirty except this shop. I kid you not. It had tile floors. The day shift was always charged with mopping the floors. You could eat off of the floor in that place when it was in its glory days. Those machines were painted forest green. And these were not the blowing engines. These were the AC generating engines. See, inside the flywheel on each one, there's a 25 cycle generator. This place was kept spotless. More people at work. Charging scrap into the basic oxygen furnace. The basic oxygen furnace took a charge very similar to the open hearth furnace, approximately 50% scrap, most of which you tried to generate in the mill, so you knew what it was, and then 50% hot metal from the blast furnace. So the scrap goes in first, and then the ladle comes to charge the hot metal. Go ahead. And here's charging the hot metal. And I put this, not really. This is Bethlehem speed. It says, this mold produced 179 pores. Excuse me, a ladle produces pores. A mold produces ingots. But that's Bethlehem speak. So often they didn't get it right. Steel ingots, I'll talk a little about these. You see the round things on the tops of these ingots. They're poured in that position. These are called bottle cap ingots. So the molds are made like bottles, inverted, just like that. You pour through the round piece at the top, fill the mold. As soon as you fill the mold, you have a cast iron cap, which goes on there. You have a bar on a pivot on the ladle where you pick these caps up off the pouring platform and put them on the top of the just poured ingot mold. And in some places, the practice was to immediately hit that with a water hose to cool it off. The whole purpose was to freeze the top of that ingot first, because in a normal ingot, the bottom freezes first because that's the first part poured. Why do you want to do that? This product was the infamous rim steel, which was done before we knew really how to deoxidize steel well. And so the opposite of a deoxidized steel is a rim steel. So this stuff had all the entrained gases possible, deliberately kept in the steel to make it solidify. And why would we do that? Because when this product got rolled, actually, I should start with solidification. As the product solidified, you had the iron-rich stuff solidify first on the outside, and as the solidification advanced inside, the crap and the gas was pushed to the inside, and that was in the center. So when you took this ingot, and with almost always sheet product that we use rim steel for, you rolled it, you got beautiful surface. But as soon as you had corrosion that went through to the middle, it went to hell in a handbasket. And that's why your cars, prior to the 1950s and 60s, would rust out so quick, because they were made of rim steel. And only when we developed deoxidation processes in the 60s and 70s to make sheet product did this product go the way of the buggy whip. And I can remember making this stuff, not necessarily here, but at Fairless Works, where I worked as a co-op student when I was getting my degree. And one of the things the pit crews in Fairless Works always did when you lined up molds to make rim steel was make sure the mold always leaned a little bit away from where you were. So when one of those caps blew off like a cannonball, it went away from you. And that did happen because these ingots were just loaded with gas. And if you didn't get that top solidified right away after pouring it, it would blow the cap right off. A very good product to get rid of. Mm-hmm. Go ahead. Any questions?
Yes.
Yes.
We have a question from someone online. They want to know if you can speak about improvements in the electric furnace melt shop over time.
Improvements in the electric furnace melt shop over time. One big thing comes to me right away. When I went into the electric furnace melt shop, there were 3 older furnaces put into 37, 40, and 41. Electric arc furnaces, briefly, great big pot, 3 electrodes conducting 3-phase current come in the top. The heat is provided by arcing from those electrodes to the scrap metal and then the bath in the furnace. So you get 3 arcs, AC current. These electrodes are held in copper holders, and those older furnaces put in had wedges on the top that held the electrodes in the holders. So if you wanted to move that electrode in the holder, and you had to every once in a while because you added a new section, you loosened the electrode in the holder, and you dropped it down lower, and you fast tighten it up again because the electrode was consumed on the bottom. Well, those holders put in the 37, 40, 41 were nothing more than great big copper wedges. And we had a 40-pound sledgehammer at the base of the furnace. So when you had to change the position of electrode, you went up on top of the furnace, and it's red hot in the furnace. You had a huge crowbar to loosen the wedge. You repositioned the electrode with the crane. Then you drove this wedge back in with a 40-pound sledgehammer. All the time you're up on top of the red hot furnace. You talk about one tough job. When the new furnaces were put in 1955, they had air-operated, spring-held wedges. So you could run them with a control on the bottom. But they didn't do that in 1955. They waited until after 62, sometime, let's say in the late 60s, to change these holders on the older furnaces. It was an amazing, amazing improvement because I saw guys go up there, reset electrodes, and come down from the furnace, and they weren't good for the rest of the shift. They were just wiped out. You just think about it. 40-pound sledgehammer on top of a red-hot roof, pounding away. But it was the job. It was the job, and you had to do it. One other thing I will say with labor, when I started in 62 and for, let's say, the remainder of the decade, laborers were always scheduled with the crew. And laborers' main job was to clean up. And if any openings opened up because somebody didn't show up or they went home earlier, for some reason, you had a labor pool to draw an employee out to replace them because all of the defined jobs had to be filled per the union contract. So that meant the shop would get cleaned up, even if only day shop. By the time hard times came, by the mid-70s, they stopped scheduling laborers. And so if the working guys who already had jobs to do didn't clean the place up, it didn't get cleaned up. And so the dirt load just got worse and worse, and it was terrible by the time we actually shut the place down in 95. In fact, I think some operations were just shut down because they got buried. So this is the combination mill. This opened up in 1969. Well, since completed late 68. 69 was its banner first year. Martin Tower, overview of the mill. I just want to talk about the people pictures because my talk was supposed to be on people. or Best Steel talk. We do it the old-fashioned, not fashioned, the old-fashioned way. Get it right the first time. And the old-fashioned way pertained to the fact we still had a mill running with steam engines by the time the place shut down in 95. The team up here, upset and ankle, and what that third guy says on the skirt. Hammer. Upset anvil, hammer, press, all forging terms. So these guys are presumably from the forging shop. Wasn't all. Here's protective clothing in the 90s, right before we shut down. This is my shop. These are three of the guys that work for me. That's Joe Bilsack on the right, Marty Castellani in the middle, and Bill Macaravas on the left. So, but they're standing in front of a pony ladle. A pony ladle is a small ladle. It has a vacuum sealing ring around the bottom. You can see that. So that pony ladle went on top of a vacuum tank that sealed the top of the tank for steel. So when you put steel in that pony ladle and you open that pony ladle, steel went into the vacuum tank. Stream literally exploded as hydrogen boiled out of it. But that pony ladle maintained the seal on the top of the tank, so you didn't get any air entrainment. So I think I was fortunate in my career. I was one of the few guys that actually witnessed almost every day steel pouring in vacuum, where you could actually see the steel. When you work on the steel furnace or you work other places where they were not vacuum pouring, you saw the steel, and almost always there was a fume in the way or slag in the way. So you didn't necessarily get to actually see the steel. When it was in vacuum, you knew you were looking at the steel. Go ahead. We have that out front right now. Made in the shop here. Ingot molds behind narrow gauge locomotive. And you notice these do not have hot tops on them. These are going for structural product, which was not rim steel, but it was semi-killed. So it wasn't killed steel, it wasn't open steel. Let me define that a little bit. When you make steel, it comes with a dissolved gas load. For any critical product, you want to get rid of that gas load. You can do it two ways. You can take it out with a vacuum, or you can take it out with chemical reagents. In any effect, it becomes what we call killed steel. In other words, it doesn't have a gas load. If you leave the gas load in completely, it's rim steel. And if you leave half of it in to make a structural product to get somewhere right in the middle, it's semi-killed. This is an ingot typically made by my shop on its way to the forge. You can see the part on this end that is round with brick around it. That is the sink head. That is the part that held a reservoir of molten metal that feeds the ingot as the ingot solidifies. So the ingot is solid when the forge gets it. The part with the flutes is the part that's solid that the forge will use. So they'll forge the solid part, the part with flutes, and then the sink head part will be cut off and discarded and supposedly properly identified and sent back to my shop so I know the alloy content so I can remelt it. That was always the bugaboo, getting these guys to properly identify their scrap. Because once the forge was finished, they didn't care whether it was identified. I was the guy who cared whether it was identified. Dumping slag. People used to line up on a summer's night down here on the east side of Hellertown to watch this happen. Actually, casting the blast furnace, that's molten iron to the blast furnace in this runner, and that's slag over here going into slag benders. So it's separated at a dam just on the outside of the tap hole in the furnace. This is open heart 3, okay. This is open heart 3, I think 1979 or 80, where it's being scrapped. And, the furnaces were on that side. The pouring bay was that side. You can still see a ladle crane and the pouring aisle hanging up there. Just give you an idea of the immensity of what these things were as buildings.
No, that's a fantastic picture.
What year was that?
They scrapped that out, I think, around 1980. I think it shut down in 79, about 1980 they took it down.
So the open heart still was running after the BOF was constructed?
Well, we had 4 open hearts in this plant. Number 1 was my shop, started in 1887, and by 1955-57, it had been converted to electric furnaces. Number 2 open hearth was started by Schwab in 1907 with 16 150 ton, 16, I don't know, they're 150 ton first, I think 100 ton furnaces first. And it was started by Schwab in 1907, was probably running by we started in 1905, so I think by 1907 it was in operation. Then when they started an alloy building, an alloy division, they built this open hearth just prior to World War I, and it ran until 1963. And it had the 6 furnaces and it made alloy steels in the open hearth. And then number 4 open hearth was built in line with number 2, and that had 5 250 ton furnaces. And the last of those furnaces didn't get in until World War II. So all of that shut down by the time the BOF came in 1969. But we had 36 open hearth furnaces in this plant, not all at one time. What's that?
The Iron Foundry building is on the right.
Yeah, that's the Iron Foundry. The original,
Not the brick building.
right, the stone building with the hip roof, right. And that originally was the Bessemer and railroad shop, right. And there's and anybody want to tell me what's wrong with that? No, it's not an I-beam. It's supposed to be a wide, but there's still something else wrong with it because the logo was not properly reproduced.
Oh, your top flange looks like an American.
Right, the top flange is tapered, the bottom flange is parallel. No, for crying out loud, they never made one like that. They made them either tapered or parallel on both sides. So somehow this got duplicated wrong and it's been just copied over and over. So we would make them parallel flanges or tapered flanges. The tapered flange was a little easier to make, of course, but the builders preferred the parallel flanges, and that's what most of the product was. Any more questions? Yes, sir.
What was sprayed on the inside of the ingot molds for the hot iron with it?
That's a good question because when I started, we used to spray them with a mixture of graphite and water. Sprayed on the mold. We're supposed to spray that on while the ingot mold was still hot from the previous use. So the water would evaporate and you wouldn't be pouring in there with any water in the mold. Of course, you can't always get a mold that's hot from the previous use. And sometimes it's so blooming hot, you can't even get next to it. In the era I was in there must have been 10 different suppliers that came in with the magic mold spray. Use our product and your ingot mold wear will be cut down tremendously. Your ingot surface will be improved immensely. And none of them ever worked. And I used to tell management this because I would watch the mold in the vacuum tank. I could look right down and watch the mold filling with the molten steel. And invariably, whatever the mold wash was, you could see just flaking off as the steel rose in the mold. And it would just become scum in an ingot in which you were trying to make clean steel. And I told this to management. And finally, I think more as a cost-cutting measure than anything else, they finally decided we won't spray the molds with anything. We'll just clean the molds as best we can. So none of those things worked in the face of, unlike a foundry where you can put wash on a sand mold and get a much better surface. But this did not work on a blast furnace iron mold. I hope you learned something.
Yes, sir.
And as you might guess, I could probably talk all night on Bethlehem steel, one of my favorite topics. And the pictures are actually from the book that the Canal Museum published that I wrote, edited by Ann Bartholomew. And It's for sale back there? Yes, if you're interested.
Thank you, Don.
Okey doke. Be sure to come back. When is the next lecture?
Yes. So we have a number of upcoming programs, companion programs. Dr. John Smith is going to be talking to us about building the Navy, rebuilding the fleet on April 7th, 6 p.m. So I hope you can return for that. Thank you, Don.
Well,
That's great.